Dear colleagues, my work is focused on microstructural characterization of calcarenite stones by thermal conductivity scanning. In this presentation, I will start with an introduction. Subsequently, I will talk about the materials and methods, then the results of my work, finally a conclusion. Many materials, natural and artificial, are heterogeneous and porous, saturated or unsaturated with fluids. The study of thermal behavior of these materials is fundamental for many applications such as civil engineering, geophysics, and historical monuments. The objective of this work: measurement of thermal property using TCS, characterize the porous network, porosity, heterogeneity, and anisotropy of calcarenite stones. The materials studied in this work are calcarenite stones used in construction of historical monument of Morocco. The calcarenite stone is sedimentary rock. It is characterized by high and variable porosity, and chemical composition is very rich in calcium carbonate. Measurement of thermal conductivity are performed on 6 samples in direction X, Y, and Z. The measuring process is based on the optical scanning method developed by Younes. It is characterized by non-descriptive measurement of thermal properties. We impose a unidirectional heat flow on the sample and measure the temperature difference across the sample. The thermal conductivity of the sample is calculated by this equation. The variation of thermal conductivity as a function of position is shown for our calcarenite sample in dry and saturated states. In dry states, the thermal conductivity is strong along the anisotropic planes X and Y direction. It is weak in the perpendicular direction Z. In saturated states, the thermal conductivity is greater along the perpendicular direction. Charlie and Rebash proposed an estimate of porosity using this equation. The variation of porosity from this equation is shown in this figure. The porosity is greater in perpendicular direction, which shows low thermal conductivity in dry states and high thermal conductivity in saturated states. Conclusion: the thermal conductivity scanning analysis allows definition of relationships between porosity and thermal conductivity at the millimeter scale. Measurement of thermal conductivity allows access to the porosity on one side of calcarenite stone. The calcarenite stone is characterized by a strongly heterogeneous structure. Thank you.